Let's study 9th standard ICSE Biology, Chapter 17, Aids to Health. Biology, Chapter 17, Aids to Health. Health is wealth, as they say. But what is the need to keep healthy? Well, without it, we can't enjoy anything in life. Maintaining our health happens at two levels. At the personal level, we have to maintain hygiene, but that may not be enough. We have to maintain the cleanliness even at the community level. Because no matter how clean your body or your house is, if there is stagnant water around your house, then it could lead to malaria, dengue spreading across the people in your neighborhood. The World Health Day is celebrated on April the 7th. This day highlights the importance of keeping oneself healthy, and awareness is spread by the relevant organizations. One important aspect of our good health is our immunity. Simply speaking, it means our body's defense against diseases. And sometimes the best defense is offense. So our immunity is of two types. One is the local defense system, which is like the police patrolling our body. They catch any foreign object, any outsider, and try to neutralize it. But we also have a specialist commandos, the immune system, which has WBCs, which deal with more advanced threats. But how do these threats enter our body? Here are the ways: directly through the skin, especially if there is a cut on the skin, through our mucous membranes, which can be eyes, nose, urinary tract, or even the genital tract, that is reproductive tract, through food or water intake if it's contaminated with germs or parasites, or through the air we breathe in. The local defense system, it has various types: the protective mechanical barriers like skin, hair, mucus. Skin, the outermost layer, is dead skin. It has a protein called keratin, which makes it impermeable, impenetrable to the germs. And yet we should continuously wash our hands, skin, our facial skin, because germs may settle there, and then if we scratch our skin or there is a cut, it gives them an entry point. Hair, we have hair in our nostrils which trap the dust, and dust has germs, so that prevents the germs from entering our respiratory system. Similarly, we have mucus. It's a slimy secretion in the entire lining of our respiratory tract or even our digestive tract. Especially the mucus in our nose and our windpipe, they trap many bacteria and dust particles. So again, they prevent them from entering deep inside our body. Another method of our local defense system is by throwing out the germs if they enter our body. This can be done by coughing, sneezing, vomiting, or even diarrhea, that is loose motions. Another method is germ-killing secretions. Our saliva, sweat, tears, nasal secretions, all of them have some chemicals which kill germs. Even the hydrochloric acid produced by our stomach kills germs, but not all of them. And finally, we have some WBCs. They are germ fighting. Specifically, they are neutrophils. You see, WBCs are of many types, and neutrophils are not specialist WBCs. They generally attack any microbe or any foreign object which enters our body. They are also called phagocytes because they do phagocytosis to destroy bacteria. This is a diagrammatic explanation of the process. First of all, the WBCs change their shape. They are like amoeba, so they can squeeze out of the blood capillaries. This is called diapedesis. Next, they engulf the bacteria and ingest and destroy it. This is called phagocytosis. Here we see how a particle is being ingested by this WBC. So this is called phagocytosis. This is a very common method of defense, but may not work against all the germs. What if there are some germs which escape this local defense system? Then the body has to rely on the next level, which is our immune system, which is highly specialized and very complicated. But we are going to study only the basics of our immune system. A quick recap: this shows our local defense system. Note that we are born with this defense system. So this is a part of our innate, inborn immunity. We don't acquire it during our life. So the merits of the local defense system are they work instantaneously. They don't depend on previous exposure to infections. We already have this system in place. And they are effective against a wide range of potentially infectious agents. But when all else fails, we have our immune system to rely on, which is not inborn. We are not born with it, we acquire it during our life. So the best way to study its types are through this flow chart. So immunity is generally classified into two categories: innate, that is we are born with it, and the acquired immunity. This innate is also called the local defense system, which we just studied, and it is non-specific. That means it randomly targets all the foreign objects entering our body. It doesn't have to identify which particular bacteria or virus it is. On the other hand, the acquired immunity is very specific, because the immunity against, let's say, hepatitis A won't protect us from polio. It is very specific, and the cause of this are the lymphocytes. They are a very special type of WBCs. Earlier, we studied neutrophils, which are just phagocytes. They're not specialists. But lymphocytes are special. But how do they identify and destroy a particular bacteria or virus? We'll study that shortly. But you may have already guessed that it is through some special chemicals called antibodies. So acquired immunity is also called adaptive immunity, because we keep adapting throughout our lifetime. Acquired immunity has further two types: active and passive. In active acquired immunity, the antibodies are produced by our own body. But in passive acquired immunity, the antibodies are supplied from some outside source. They are further classified as natural or artificial. Let's talk about actively acquired immunity. If it's naturally acquired, it's simply because we were infected by it earlier. So if you are infected by a COVID virus, then you have fought it, you have produced antibodies, you have destroyed the virus. Now those antibodies will stay in your blood for many months and you won't be infected again by the same variant. So that's a naturally acquired active immunity. Artificially acquired would be through vaccinations. So if you don't want to risk getting COVID, you would rather take a vaccine which would stimulate your WBCs to produce antibodies, even though you will not suffer from some disease. But the antibodies will be prepared. So you are well trained for any future battle with the actual COVID virus which may enter your body. So that's artificially stimulated, but it works well. Passive immunity, again, natural or artificial. Natural passive immunity means that the antibodies were received by the fetus, that is the small baby in a mother's womb, by the mother's blood. The fetus is too small to produce its own antibodies, but it can get infected if the mother is infected. So the mother will produce antibodies not only to protect itself, but even the fetus. So since the fetus is not producing its own antibodies, we call it passive, and it's happening naturally. Artificial, well, here we inject the antibodies from some other animals into a human being so that he can get an artificially acquired passive immunity. Let's take an example of tetanus. Now, imagine a person is already suffering from tetanus or diphtheria. Perhaps he did not get vaccine in time and is suffering from the disease. A battle is going on, he's producing his own antibodies, but maybe it's not enough. Maybe his immunity is weak. Now we can't leave it to chance and hope that he gets well on his own. What if it becomes fatal? So to complement his own immunity, to have a backup support, let's borrow some antibodies from a horse and inject it into the patient so that he can be treated. So understand that this is different from vaccines. vaccines are given before you suffer from the disease. It's a preventive measure. Whereas serums, which have antibodies, are given after a person is suffering from a disease. So it's a cure. So the procedure is that tetanus bacteria or the diphtheria bacteria or the toxin produced by this bacteria is injected into a horse in small quantities and in inactive form. So don't worry, the horse won't be harmed. And then the horse will produce antibodies as a reaction to the injected germ substances. So in his blood, antibodies will be produced. Now all we need to do is draw out the blood from the horse and filter out all the WBCs, RBCs and platelets and only keep the liquid part, which is called plasma. But in this plasma, again, we have some proteins called fibrinogen, which helps in blood clotting. Let's remove that as well. So what is left is serum. It's a watery substance. It has some dissolved salts or some nutrients, maybe hormones, but more importantly, it has antibodies. So we have borrowed this serum from an animal and we are going to inject it into the patient. That will give him artificially acquired passive immunity to fight that disease. Same thing can be done for anti-venom injections as well. If you are bitten by a snake, you need an antidote, an anti-venom injection, which contains antitoxins or antibodies. But from where do we get it? Well, it's possible that it has been obtained from some animal. Maybe the poison in small quantities was injected into a horse or any other animal. So they were induced to produce antibodies, and now we use their antibodies in our body, because if we wait for our WBCs to start producing the antibodies and destroy that venom, it might be too late. Let's have ready-made antibodies ready to save lives. Now, definition of immunity. Please add the words which I've written, because it could be not just because of harmful germs, but also germ substances, which is the toxins released by the germs. The kinds of immunity: number one, innate immunity. That's because of the local defense system. That's a definition here. Now it's wrongly classified into non-specific and specific. That doesn't make sense. It is non-specific only. So cancel the sentences given here. However, if your school teacher insists on learning what is there in the textbook, then oblige her, because she's going to check your paper. But this is the correct information, well researched from medical websites. An example of innate immunity is that all of us are already immune to certain diseases which affect animals or plants, but we human beings never get affected. Example, distemper. Distemper is a disease which affects only dogs. It never affects human beings. Fortunately, we are born with an immunity against it. That's not a specific immunity because we didn't acquire it in our life, we were born with it. Similarly, we have a definition of acquired immunity here, and then we have definitions of all the types which I've already explained. So you need to read all of this and remember the examples. Now, when we acquire immunity thanks to our WBCs, specifically the lymphocytes, there are various ways it is done. They produce antibodies, specifically by lymphocyte B cells. Sometimes they produce killer cells, which kill the germs in another way, not by producing antibodies. That's by lymphocyte T cells. But all of that you'll study in detail in 10th standard. There are some lymphocytes which are called memory lymphocytes. That means even after the war is over and you won it and you are cured, these lymphocytes stay for a long time. They retain the memory of how to defeat the enemy, so that, let's say 6 months down the line, if you're infected again, you're already prepared to win the battle even before it starts. This is how antibodies work. They clump all the bacteria together, thus neutralizing them, and then they wait for some big phagocyte to come and just ingest it and digest and destroy it. Antibodies are basically proteins. They are a class of immunoglobulins. Antibodies are very specific. They are produced by the lymphocytes on exposure to an antigen, full form antibody generator. You see, every germ has a chemical called antigen on its surface. This is the identity of the bacteria. When a WBC notices this antigen, accordingly it produces this relevant antibody. And that's why for every different species of bacteria, a different antibody has to be created. Fortunately, we have the ability to make unlimited variety of antibodies. Every time you are infected, a new antibody type is created in your body. But that's not going to give you permanent immunity. That's going to last for a few months, a few years. Antibodies are very specific. Difference between active and passive immunity. This is produced by our own body, received from outside. This is because of getting infected. Here it's ready-made from outside. Active immunity is better. It's long-lasting. Whereas passive immunity is less effective and it's temporary. This will be effective only after a certain time gap. So if you get infected, it will take time for your WBCs to prepare the antibodies. Then only they can attack the germs. Whereas passive immunity is immediate. So both have their pros and cons. Here's a summary of whatever we just studied. AIDS is a disease where the HIV virus is very smart. It keeps changing its genetic makeup, its constitution, to escape our immunity. We are not able to recognize it and create antibodies again and again. In fact, they destroy our WBC T cells. So a major chunk of our immunity is destroyed by them. So our immunity becomes so weak that any other normal disease, like even a cough and cold, could kill us without relevant medicines. Vaccination is also called prophylaxis. So we inject a germ or a germ substance, and hence we develop an immunity against a particular disease, which makes us immune for some time. There are 4 categories of vaccines produced. First of all, a vaccine may have killed germs. Examples have to be studied. TAB vaccine for typhoid, Salks vaccine for poliomyelitis, which has saved millions of lives. And even the vaccine for rabies has killed germs. So when a dog bites you, an unvaccinated dog, you should immediately go to the doctor and start taking the vaccine for rabies, because by the time the war starts, you still have a time of 24 to 48 hours to train your WBCs to produce the relevant antibodies so that they can destroy that rabies virus. You see, viruses won't start multiplying immediately on infection. There's a short incubation period. In fact, HIV has an incubation period of almost 10 years. Living weakened germs. Here, the germs are not dead, they are alive, but they are weakened, so they won't harm you. But that's a good way of stimulating your WBCs to produce relevant antibodies. Example, the vaccine for measles or the vaccine for tuberculosis, which is called BCG, which has the bacillus of Calmette and Guerin, the French workers who developed it. Third type of vaccine is a living, fully poisonous germ. For example, there's just one example, smallpox vaccine. Do you know what is there in the smallpox vaccine? An alive virus called cowpox virus. Fortunately, it is not very harmful. If you are infected with this, you will have a boil on your hand. But then at least you will be immune to smallpox, which is deadly. This was discovered by Edward Jenner, who saw that the milkmaids who would suffer from the cowpox because they were milking the cows and they would get boils on their hands, but they were never suffered from smallpox during an epidemic. Next, the fourth category are toxoids. There are certain toxins secreted by bacteria, example diphtheria and tetanus bacteria, which would be very harmful. We add formalin to the toxin, and now they are called toxoid, so that they won't harm us. But if we inject it into our body, our WBCs will recognize them as foreign substances, produce antibodies. So then later, if the real tetanus or diphtheria bacteria produces harmful toxins, we are ready to neutralize it. So this is a vaccine. Understand that this vaccine is given before the infection symptoms start. Earlier, I explained about serum for diphtheria and tetanus, but that has ready-made antibodies from outside, and that is given after you are suffering from the disease as a cure. Attempts are being made to develop a vaccine against AIDS also. Till now, we've not been successful, but let's be hopeful that it's possible one of you might be able to discover a breakthrough. I'll give you 10 years. Mark the definition of vaccination and immunization. What's the difference? Well, write the sentence: immunization is a consequence of vaccination. Vaccination is the process of introducing the germ or the germ substance, whereas immunization is the development of the resistance. So first we vaccinate and then we get immunized. By the way, you can get immunized even without vaccination by suffering from the disease. But I'm sure rather than that, you would prefer getting vaccinated. Although you need to check if the vaccine has some severe side effects. In that case, it's better to suffer. Immunization has been done in India on a mass scale for certain diseases. Polio has been a great success, the anti-polio drive, the polio drops. Polio has been eradicated from India, but we need to continue giving polio doses to all the kids and the newborns because it's not been eradicated from the world yet. The virus is still there in the neighboring countries. Here is a schedule of national immunization. It's not important, but the abbreviations are important. You need to know these names, full form. And remember, the first vaccine given to a baby is DPT, diphtheria pertussis. It is a cough where there's a whooping sound when you cough, and tetanus. Now, certain terms. What's the difference between antitoxin and antibody? Well, antitoxin is also produced by a WBC against a toxin. This is the definition of toxin. So, antitoxin is actually an antibody itself. It's just a special name given because it's not acting against some virus or a bacterium. It's acting against some poison, some toxin produced by an animal or a plant or a bacteria. So all antitoxins are antibodies, but all antibodies are not antitoxins. This is the definition of antibody. This is a repetition, you can cancel this. Next, let's understand the difference between antiseptics and disinfectants. Antiseptics are mild and disinfectants are strong. So antiseptics can be applied to our skin, but disinfectants can't be applied to our skin. They are too strong. They are applied on spots of surfaces. And examples have to be learned. Iodine and phenol. We can't obviously apply phenol on our body. It's too strong. It's for the floors and the toilets. All examples have to be learned, but notice that sometimes the same example is given for antiseptic and disinfectant. So you can differentiate it by writing dilute Lysol here and conc Lysol here. There is a type of disinfectant called physical disinfectant. There are no chemicals involved. Example, strong heat and boiling, because they also destroy germs. Final topic is antibiotics, life-saving medicines which have saved millions of lives thanks to its discovery a century ago, almost a century, by Alexander Fleming. He noticed that when he accidentally spilled some mold, some fungus called penicillium, on a bacteria in a petri dish, the bacteria was called Staphylococcus, he saw that the fungus is producing some chemical which is killing off the bacteria. So he extracted that chemical and he realized that it can be used to kill bacteria in our body as well. Hence the term antibiotic, which are chemical substances produced by some germs, microbes, and they can kill or inhibit the growth of other microbes. Penicillin was the very first antibiotic produced from penicillium. Please understand that Penicillium notatum is the name of the fungus and penicillin is the name of the medicine, the antibiotic, the drug. Fleming produced it from Penicillium notatum, but then later researchers started producing it from Penicillium chrysogenum. And today, we don't even produce it from a fungus. We manufacture it synthetically, artificially, using some raw materials in the lab. The second antibiotic discovered was streptomycin, and this time it was being secreted by a bacterium itself called Streptomyces, and this was useful against some other disease-causing bacteria. You can cancel this paragraph. Uses of antibiotics, well, it helps us to fight infections. However, now the antibiotics have been so overused and misused that the germs are becoming resistant to antibiotics, which is dangerous because, again, the curable disease might become incurable. We already have antibiotic resistant TB, tuberculosis. If somebody suffers from it, then no medicines would work and the person may even die. So we should always use it only when the doctor prescribes for it. And please understand that antibiotics cannot kill viruses. It's not possible. They only kill bacteria. Sometimes antibiotics are added in food preservatives like meat and fish as well, so that they don't get spoiled. So here the antibiotics work as food preservatives. Animal feed or animal food can also be treated with antibiotics because the food is not so hygienic, so they know that the animals will suffer from some diseases. So as a preventive measure, antibiotics are added, which is wrong because its overuse of antibiotics is what is leading to antibiotic resistance. Also, it can be used for controlling plant pathogens. Cancel the blue box, cancel the first paragraph here. There is another group of medicines called sulfonamide or sulfa drugs, which are very rarely used now. The very first such sulfa drug was salvarezon, which was used to kill germs of syphilis, it's a disease, and sleeping sickness. No, what you have is laziness, not sleeping sickness. Another two examples of sulfonamides are sulfadiazine and sulfanilamide. That's all you need to know. Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.